Good morning, everyone. It is Monday, March the 30th, and we have several days of severe weather on the way. Now, starting on Monday, you'll notice that we have this storm system over the northern Rockies, and that'll begin to move off to the east during the day Monday, and this will begin to spark some severe thunderstorms, perhaps in the state of Michigan, even down into the states of Illinois, Missouri, and perhaps further south and west back towards Oklahoma and even Texas. One of the big differences you'll notice this time around is that we have a lot more activity here in the Intermountain West. We see chances of rain and snowfall over California, Nevada, Utah, and even Colorado, especially as we get into the Tuesday, Wednesday timeframe. Notice that the rainfall extends into the northeast as we get into the Tuesday, Wednesday timeframe as well. And the rain snow line is much further to the north. We're talking about northern Maine before you start seeing wintry precipitation. So let's take a look at the trough ridge pattern this week. Again, just as a reminder, where you see blue, that's where we have troughing taking place. That's where cooler temperatures move in. Also, we have rid on the map here. That's indicative of ridging. And that's where we have typically warmer temperatures moving into a region. And we see here early in the week where we have ridging building into the east, right? We're seeing those warmer temperatures move into the Ohio Valley and even the Northeast as we get into the day Tuesday. So we're going to see those temperatures begin to warm up again over the Northeast. Meanwhile, the northern tier of the country, from let's say Oregon State to the Dakotas and even Minnesota, we're going to start to see those temperatures begin to cool down again, where daytime highs are in the 40s. And this will be the precursor. Well, we could see some heavy spring snowfall in these areas, especially into the state of Minnesota. Now, I want to direct your attention to the black lines on the screen. These are the contour lines, and where we have them the tightest or the closest together, that's typically where we have the greatest temperature gradient and also the greatest pressure gradient. Or, in other words, that's where we see the most significant change in temperature, right? This is a good area to pay attention to because that's where we see the most dynamic weather take place, whether it's the change in temperature or, let's say, even precipitation, right? Some of the heaviest precipitation can happen in this zone. In fact, the most active weather is usually on the southeastern quadrant of this tight gradient. In this case, on Tuesday, we could see some severe weather all along from Iowa, Illinois, into Michigan. In fact, during the day Monday, I think there's a severe weather chance in Iowa that will be extending eastward into Michigan. But this is more pronounced as we get into the day Tuesday, where even there's a marginal risk of a tornado taking place in the state of Michigan. Now, the National Weather Service for that day Tuesday shows the chance of thunderstorms from Texas all the way into the Northeast. And there's two areas of a slight risk of severe weather over Texas and Oklahoma, and a second area over, let's say, the Great Lakes and the western part of the Northeast, so western New York State, also near Lake Erie in Pennsylvania. That's another area where we could see some severe thunderstorms take place. But again, take note of this yellow region here around Chicago to Fort Wayne and even into Detroit. So if you live in Grand Rapids, even, there is a chance of severe thunderstorms, and some of these could produce a tornado during the day Tuesday. Now, one thing that's good to look at are soundings from these model runs and to see the potential for the severe weather due to one shear and then also the convective available potential energy. So these two factors really come into play when we're talking about the development of supercell thunderstorms. Now, there's two big relationships to take note of. One is the relationship between the green and red lines here on the screen. And where they first meet determines where the lowest clouds can form, typically in the atmosphere. And it's also the area where we can see the parcels of air become saturated. I'm going to point that out for you guys here on the left-hand side. Somewhere around 850 millibars, we could see the development of the lowest cloud level. Now, what makes this tricky is sometimes we'll see the temperature actually warm up in the atmosphere. You kind of notice this here starting at the bottom, how the red line kind of goes up and to the left. And it only does that for so long, right? It goes up to that point where it basically meets the green line. I'll kind of circle that again for you. And then notice how it diverts back in the opposite direction. That's actually indicating some slight warming And where the atmosphere actually heats up, that can actually prevent clouds from forming and precipitation from forming. And I'll highlight that for you guys here so you can see it. So this region here where it kind of diverts back to the right, that's indicating some warming in the troposphere. An important thing to note here is when that happens, that acts as like a cap, like on a soda. So you can imagine like mixing up a soda can and then keeping that cap closed. Well, that energy can't get out of the bottle unless you open the cap, right? Well, the same thing is true for the atmosphere. All this energy is building throughout the day from the heating of the earth. However, if that cap is not removed, we're not going to see those strong thunderstorms actually form. But here's the second biggest piece of information here. Let's say that we were to have the moisture and the temperature meet up at that point that we were talking about, around 850 millibars. What this illustrates for us is the potential for a saturated parcel, and that's indicated by the white dashed line here and its movement up in the atmosphere. Whenever a parcel of air is saturated, it cools at a much slower rate than dry air. In fact, take a look at the red and white lines here, especially in this section that I'm drawing a circle around now. Notice that the red line cools down at a much faster rate here. In other words, it moves off to the left much quicker than the white line. Again, that's all because the saturated parcel is cooling at a slower rate. So it's kind of staying on a warmer side, right? On the warmer end of things as they both move up in the atmosphere. In fact, there's a gap between the two all the way up into the top of the troposphere here. Let me kind of circle that region for you here. You notice that that white dash line is to the right of the red line. And that distance, that gap between them actually determines how much available potential energy there is for thunderstorms when they form in these kind of conditions. So if you see a big gap between the two, there is the potential for strong thunderstorms if one were to form. And what it has to do is overcome the cap that we're seeing near the surface of the troposphere. Then what it has to overcome here is that capping feature. Kind of highlight for you that in that white box there. Again, where the temperature is actually warm briefly right in the troposphere. If the temperature is warm enough at the surface, so you see we're at 75 degrees here currently, right, in this particular image, I'd say it warms even further throughout the day to maybe 80 degrees. What might happen is that red line actually goes back to maybe here. And if it lines up with what's above it, then we'll actually see the temperatures cool at a steady rate all the way up the troposphere. Now, as long as that cap is in place, we won't see any storms develop. And that allows the energy just to kind of continue to build, kind of like shaking that soda bottle, right? Until it pops, until we get to maybe 3 or 4 in the afternoon. And for those that live in the Great Plains and they're in regions where we see this a lot, the capping of the atmosphere, around that time during peak heating, boom, you'll get these giant clouds that form suddenly, and you'll see these supercells take form. And all of a sudden, it becomes very dangerous very quickly. So I've highlighted the convective available potential energy here in red. Again, that's that area between the white line and the red line I was showing you before. Again, the greater that red area, the more convective available potential energy for these thunderstorms that are forming. I've also highlighted here, again, going from 1 to 2 here, at position 2, a bottle cap, right, indicating where that capping is taking place in the troposphere. And that's that little notch here we were showing, right, where it's briefly warming for a time. And the cap is not necessarily a bad thing if you want to have thunderstorms. It can be a very good thing to kind of build that energy at the surface until it overcomes the cap by 3 or 4 in the afternoon. Now, the third thing I have highlighted here is the wind and how they change at the surface. I've highlighted the first kilometer here because that can tell us a lot about the changing winds with height. And if you see these symbols here at the bottom, again, where you're seeing that blue there with these flag-like features, you'll notice that we have tick marks indicating the wind speed here. And there's more tick marks as you go up in the atmosphere. And what that's showing is that the wind speed is increasing. But another thing that's very important here is that you'll notice that the direction is changing, right, with time as we're going up in the atmosphere. And what that's doing is that's creating spin in the atmosphere. And that could lead to not only the development of strong thunderstorms, but also the marginal risk of a tornado. Well, so take a look to the right here in the upper part of the screen. Again, I've highlighted that as 3 as well. And what I've done here with the cyan blue is I've shown that first kilometer and how the winds are changing with height. And the more turning you see in the atmosphere, this is the hodograph, by the way, the more turning you're seeing there, the more likelihood we could see spin in the atmosphere. And this again could lead to a risk of a tornado. And this particular sounding here, we're seeing a marginal risk of tornadoes. Kind of highlighted that in the arrow there where the possible hazard is indicated. And if you wanted to see maps like this, again, you could go to a place like pivotalweather.com, and that's where I got this particular sounding here. Guys, you may have noticed from the sounding that we not only saw the warming of the temperatures with height at a certain level, but we also saw this drying of the air as well. And we noticed that green actually moved off in the opposite direction, right? It actually dropped in temperature much quicker. And it showed this region of very dry but also warmer air in the troposphere. Highlight that region for you just to kind of give you an example here off to the right. So, what creates that? And where does it typically happen? Well, where it typically happens is on the eastern side of the Rockies, because not only do you have these high mountains around at 10,000 feet, you also have a plateau region that's around 5 to 6,000 feet around places like Denver. And one thing you'll notice is that in that region right now, very dry conditions, right? And it's much drier than, let's say, positions to the east, right? Let's say you go a couple of states to the east, it's not that dry. But one thing that happens and what's not evident necessarily, especially if you're driving from Denver eastward to a place like Iowa, is that the elevation drops quite a bit. And you may notice that in Denver it's very dry, but you drive out to a place like Iowa, it's a lot more moist, right? You might have a lot more rainfall there. But one thing you may not have considered is how that air at higher elevation moves over, let's say, places like Iowa that might be 500 feet to 1,000 feet versus a place like Denver that's around 5,000 feet. Now, one of the more interesting things is that this dry air that's just downwind of the Rockies, when it moves over, let's say, the Great Plains and further west into the Midwest and the Southeast, is that it's rolling over moist air. And those two air masses have trouble mixing with one another. Now, when this warm, dry air comes off the Rockies, again, kind of indicating this region here at about 5 to 6,000 feet, moves from west to east, it has trouble mixing with the air down below. So, again, I'm going to just kind of highlight this region. When it moves into that area, it just kind of locks in place overhead. It has trouble mixing because the dry air has a different density than the moist air underneath. And especially during the early morning hours, this moist air could be cooler than this dry air above it. And I've highlighted here, this would be like an example around maybe 10 a.m. on an afternoon in April or May that you could see in these particular soundings. Now, what will happen as we move through the afternoon in these places is that the temperatures at the surface actually warm. And what if they do warm by 10 to 15 degrees? What does that do to the next sounding that's taken in the afternoon? Well, if the temperatures do warm at the surface, this red line that you're seeing at the surface, again showing the 50 and the 65, is going to actually move off to the right. And when it does that, it has the potential to align with what we're seeing above it. And if it does, right, connect to that line perfectly, what might happen is that we might see cooling with height all the way up the troposphere. And what that could act to do is remove the cap there where temperatures briefly warm in the troposphere. So again, going from 50 to 53. It may not be 50 degrees there as we get into maybe the 3 p.m. time frame in the afternoon. So in the next image here, I've kind of indicated, again, it's not perfect by any means, and I think any meteorologist looking at this might be like, hey, it doesn't look like that exactly. But what I wanted to show you here is that the air in this case is moistened even um, as these temperatures have warmed. And what could happen in these cases where we have a cold front coming out of the northwest is that usually in front of it, we might have more warm, moist air pulled up from the south. And that could bring up not only warmer temperatures, but higher dew points. And I've tried to indicate that here in this particular image where you've seen the green and the red kind of matching each other going up in the troposphere. And it's going up again to that same height that we saw before. That was a temperature of 53. Well, now it's cooling with height all the way up, and that cap is now gone. And one thing I've done differently than what you saw in the soundings that we talked about a white dash line before. Didn't really do it here. I've got a black dash line indicating the saturated parcel rising with height. Again, that's going to cool much more slowly than the drier air around it. And that's going to create a lot of cape, right? So again, I'll kind of indicate that that red region again is the cape we were talking about. That's fuel for the thunderstorms that could develop in the afternoon. And what's kind of cool about all of this is that same cap, right, that was preventing the thunderstorms from forming in the first place is actually making them stronger the longer we wait into the afternoon. So, again, if we're having to wait till 3 or 4 p.m., it's allowing for that energy at the surface to kind of build until those thunderstorms explosively form, right, in the late afternoon hours. So, guys, I'm going to start us off Monday morning where you can see that low pressure forming over the northern Great Plains. On the northwestern side of it, we're having that rain and snowfall form, and that will begin to move off to the east right into the Great Lakes region with time. So, yeah, let's just step that forward and see what happens here. We can see where we have rain forming over the east, even into, let's say, the Ohio Valley in the northeast as we get into late Monday. And then that low pressure system actually begins to move into the northern plains early Tuesday morning, and we start to see those thunderstorms develop over places like Wisconsin. Now, the unstable air here that we have over Iowa and Wisconsin will only become more unstable with time as it moves off to the east. And we can see by the time we get into Tuesday afternoon, we start to see thunderstorms throughout the day in Michigan. Now, what we're seeing here is that we do have severe thunderstorms from Michigan down into Illinois through early afternoon. And the severe weather potential will actually begin to move back to the south and west later into the evening Tuesday. And we can see that here as we go into, let's say, Tuesday around 6 p.m. Central Time. We can see those thunderstorms that could develop over parts of Missouri into Oklahoma, maybe even a few thunderstorms down into Texas at this time frame. Another thing you'll notice here is that we do have some rain and snowfall over the west from California eastward into the western portions of Colorado. And yeah, this will be some beneficial rain and snowfall for you guys. Another thing you'll notice is that we do have mixed precipitation in the state of Maine, but again, it's kind of limited to that state alone. We're seeing mainly rain to the south and west of there. So whether you're in upstate New York, Vermont, New Hampshire, a lot of those snow chances are going to start to dwindle as we get into the month of April. So what happens beyond Tuesday? We can see here as we move into, let's say, Wednesday morning, there's some mountain snow here over Colorado, so especially over western Colorado here. Also into Nebraska and let's say South Dakota here, we see some chances of snowfall there. And we have another system moving into the West Coast, right? So we're seeing in Northern California, Oregon, and also Washington State. See some rain and mountain snowfall there. I want to draw your attention to, let's say, much of Texas into the Midwest. I think this region in particular, there's the potential for greater than 2 inches of rain this week. And we'll have several systems that form over the Great Plains and kind of move into the Great Lakes. And during that Tuesday time period through Thursday and then again on Saturday. So again, we have potential for many days of showers and thunderstorms through this area. And places that see over 2 inches of rain, again, potentially up to 4 inches of rain over Missouri, Illinois, places like that, we could see some flooding, right? And going beyond Wednesday, we can see where the rain continues over, let's say, the central plains. Snowfalls begin to South Dakota, Minnesota, that area. Again, the placement of that snow could change in the next couple of days, but a good chance of rain right through the Ohio Valley, even into the mid Atlantic. We can see the chance of showers and thunderstorms here. moving into the region. But notice also we have some heavy rain moving into Northern California and Oregon State, and likely some heavy mountain snowfall in the same region there during the day Wednesday. Now, I'm just going to kind of play this out for you guys, but I want you to kind of see the trend. We're going to have, again, the chances of rain moving through the Midwest and the Ohio Valley. And this kind of just continues throughout the week. You can see here that there's the potential for some severe weather, right? Again, once we get into Saturday over Oklahoma and Texas. And this might be an area highlighted by the Storm Prediction Center. Again, I would stay tuned if you live in Texas, Oklahoma, up into Kansas. Again, really anywhere through this entire region here, because and the position of these strong thunderstorms is going to be highly dependent on the position of that trough. So I'm kind of highlight that for you here over the northern plains. Again, that position a little bit further to the north, a little bit further to the south will impact how strong these storms could be, but then also the position of these storms. And even after Saturday, we notice that the heavy rain moves into Texas, Oklahoma, Arkansas, and back into the Midwest. Notice that we could have some really heavy snowfall right in the Dakotas and back into Minnesota and Wisconsin. So that could extend even into the UP of Michigan later this week with this particular storm. And again, that rainfall just kind of pushes off to the east, but begins to kind of die out over the mid Atlantic and southeast. Holds together a little bit more over the northeast. So you guys over New York State and Pennsylvania, you might see a bit more. But whenever it runs into the southern Appalachians in particular, it tends to kind of just die out. So this leads to a wide range of precipitation totals for the next week. You can see here a broad region of pink and purple on the map, and that's anywhere from an inch and a half to 2 inches of rain over the states of Texas, Oklahoma, especially over Missouri, Illinois, that we had mentioned before, and Indiana, and even into Michigan and Ohio, western Pennsylvania, western New York. So there's a broad area here that could see over 2 inches of rainfall. And in particular, where you see the red on the map, so Missouri, Illinois, back into parts of Kansas, perhaps even into Indiana and Michigan, there could be some areas here where we have these heavy thunderstorms that form Tuesday, Thursday, and Saturday, or we could see over 4 inches of rain. And this could lead to localized flooding. So just be aware of that this week. Elsewhere, if you live in the southeast, you'll notice that with these storm systems, you're not going to get a whole lot of rain. So if you live, let's say, east of the Appalachians from Florida to Georgia through the Carolinas, Virginia, you're not going to see much rain. You might see a quarter to a half an inch of rain in general. Of course, if you see a shower or thunderstorm that's a bit heavier, there could be some isolated areas that get up to an inch. Unfortunately, if you live in West Texas, eastern New Mexico, let's say eastern portions of Colorado, parts of Kansas, there's a region in here that won't receive anything from all of these storms that come through. Again, you're kind of providing the cap right to the atmosphere for places downstream. However, over the Intermountain West, especially in the higher elevations, we could get some beneficial rain and snowfall here over Utah, portions of northwestern Colorado, Wyoming, and also Montana. You'll notice here along the shoreline of Northern California and Oregon, we could see, again, over an inch of precipitation here, as much as 3 inches of precipitation throughout this week. I think if you live in Portland or let's say up to Seattle, expect anywhere from a tenth of an inch to as much as that half an inch of rain. There'll probably be a wide range of precipitation totals this week. Well, guys, we'll leave it at that today. I hope you enjoyed today's video. If you did like the video, please leave a like or subscribe. It really helps the channel. I hope to see you guys Thursday for the next video. Bye for now.